Now this is what we did. We went ahead and when we originally started with the unit circle or with trig functions, we specifically identified that the tangent was a composition of y over x. And actually, I have it written on the board. When y'all test it, you look for values over y over x. That was our focus because that was part of what we're doing. Now our focus is going to shift from this y over x and define them in terms of its trig function. So tangent is really a composition of sine theta divided by cosine theta, which is the same thing as y over x. And cotangent theta is the composition of x over y, which is defined as cosine theta divided by sine theta. You don't need to write down the recall identities. Just write down notes of trigonometric identities, and then write down the two quotient identities. We are going to use this to our benefit so you could solve certain trig functions. Now, one thing I do want to add, we're going to use, I kind of want to add two additional ones that are equals to these, or equivalent to these, better put. They're equivalent to these. They're not inside your, actually, your identity, your trig identities half sheet. They're not in there, but you're going to see them quite often, or they may be in there. Let me look. See if they're in there. No, they're not in there, but they're important to know. They're important to know just because of their usefulness behind it. At times, we're going to be working with sometimes the square version. What I mean by square is that if I square, does everybody have these two written down? Okay, I want you to write these in additional to these. So if I square tangent theta, that means that I have sine squared theta and cosine squared theta. Same thing with cotangent. If I square, you're going to have it like this. Now you might find the square to be in the usual place, but that's exactly how they write squares for these trig functions. They put the square specifically where y'all see them, and I think the reason why they do it is in order to make things easier for you to write. Instead of writing a parentheses around it with the square, it was easier, faster, probably more efficient just to do it this way. That's the only reason I could think about why they do it this way, as opposed to placing it the other way. But these, we're going to be working with these as well. Now the other ones that are important are the reciprocal ones. If you dealt with cosecant, that was really 1 over y, which was really 1 over sine theta. That was another one that was important. Same goes with secant. Secant theta was really 1 over cosine theta. And then let me scroll down so you can see the very last important one, which is cotangent. Its reciprocal was just 1 over tan. Our focus now shifts on the actual identities of them. All right, good. Now with these, let's go ahead and move into something that is very important, which is actually the identity. It's the one that forms, most of the identities are actually formed with the idea of this. Draw the unit circle. Draw the unit circle. You don't have to write everything above, but draw the unit circle with the triangle that you see there. Please do that. draw the unit circle and draw the triangle that you see there. And the reason why we're doing this is because we're actually going to develop, we're going to use something that is, you use it's not new, you use it quite often. It's something that's very safe to you because you did it so often. But one of the first things that we remembered, let's just keep on getting stuff. All right. Now, one of the first things that you did was you actually have a lot of experience with is with Pythagorean theorems. We went ahead and made it very clear, a very important fact, that the radius on any triangle inside the unit circle was a radius of 1. And we said that if we took any x value and any y value, that made a point inside that unit circle. But there's something additional as well. If I apply the Pythagorean theorem to this triangle, then I could go ahead and very easily say x squared plus y squared is equal to 1. And that's lovely. We did that actually. We would actually use that to our benefit to manipulate some of these equations. But we're going to take it a step further and add trig to it. If y'all remember, what is x equal to inside the unit circle? X equals, do y'all remember the equals cosine theta? Now we said that the cosine of that triangle was equal to x, and that's actually one of the things I have written up on the board. When you took your test, you found values specifically off the unit circle because I told you cosine theta was x. And the same thing we said that we said y is equal to sine theta. So with this, I'm going to add a new dimension to Pythagorean, because if x squared plus y squared is equal to 1, then I could say that cosine squared plus sine squared, sine theta squared, is also equal to 1. The only thing that will be new, though, is that we don't write the squares as what you see there. We write the squares like this. The way you're going to see the identity property expressed to you is going to be in this manner: cosine squared theta plus sine squared theta. This is universal worldwide. This is the accepted way to write trig functions. They go ahead and they tell you, or you write them in this fashion, and where you are. And this is actually our first identity function, other than the ones we defined, the basic ones that had to do with the tangent, the cotangent, the first 6 ones. This is the first important one, in which this is one of them. We're actually going to develop 8 others that come from this one. From this one. That's the reason why this one's so important, because 8 others depend on this one. Now, what is one of the other ones that depend on it? It's actually going to be the and the other 2 are easy off this one, because if I manipulate this equation a little bit, for example, if I go ahead and I take cosine squared theta and sine squared theta, and I decided to isolate, let's say, cosine squared theta, meaning that I remove sine squared theta, I will make a new identity function just off the isolation. The next identity function that we are developing is cosine squared theta is equal to 1 minus sine squared theta. Here's a new identity function we just developed off the manipulation and isolation of one of the other ones. So here's the second one. There's a third one that is developed pretty easily just by isolating the cosine. So instead of doing, so let me go ahead and rewrite it again. Cosine squared theta plus sine squared theta is equal to 1. If I isolate the sine, and if I subtract cosine squared theta, so very similar to Pythagorean theorem, just with trig, you pretty much have the same properties. And these were examples of that you would use in regards to when you had to find the leg of a property, given the leg and the hypotenuse. So this is another new one that we developed. So we're up to 3 that we just developed. 3 identity functions that came about from just the use of our first one. And you got to think there's 6 more, right? I'm talking about these 6 other ones that actually get developed from that same one. Now, how do the other 6 get developed? Well, let's start with, we're going to take the next one at chunks of 3. If we decided, actually just write this down. Hold on a second. Not this one. This one is actually, this. Ask yourself this question, and you may want to write this down. Divide the original parent function. The original question, if we divide everything by cosine theta. This is the question. What will happen if we divide everything by cosine theta? One of the effects that is going to result by the cause of dividing everything by cosine squared theta is that we're going to develop a new function as well. You don't have to write down to simplify this expression. If you want, you could just write simplify, and then I'll work with you in showing you the effects of the simplification, the result of what is going to occur from simplifying this original function by the division. Let's work on simplifying now. If I simplify this function, this is what's going to happen. Okay, first of all, the easiest one to first deal with is this portion right here. Do y'all see this portion right here? Because we all, anytime you have a trig number or whatever equation divided by the same equation, don't they cancel out? Which means that they become a value, it leaves the identity property of 1 in its place. Or you can think about it, this anytime you have the same number divided by the same number, that's always going to generate the same number. It's always going to be 1 because of the property that we have. Now, this next one right here, isn't this similar to the first one we wrote down with the tangent theta? Don't you remember that tangent? We wrote down that tangent squared theta is equal to this, which means that this is really tangent squared theta. Let me rewrite this though and place it above it. This section of this portion right here is really tangent squared theta. So I have most of my function built on the left side. I need to build the right side. But for that, I'm going to take one of the trig identities and do something similar to what we did with the tangent function. Do y'all remember that, like this one right here, the 1 over cosine squared theta? This one is really, this is similar when you have 1 over cosine theta. It references over to our property, our important property secant. Now, if I went, it doesn't look exactly the same because the one I have up on the board, the one I wrote down in black, currently that one is not, it's non-squared. But I'm able to square it. Now, if I square it, it's going to take this form. Square, square, square. And you might be saying, but hey, it doesn't equal still. I can't because there's a 1 squared and there's a 1 over here that is not. But what is 1 squared? What, right? So that means that they do equal, which means that this last portion that's right here really equals secant squared theta. So here's your here's my 4th trig identity that we just developed. That this is the first time, this is something new that you're seeing for the first time. Now we also have the ability to take this trig identity and manipulate it. You remember how we're able to, and they wrote it down here. I'll do it with this one. I'll do a simple manipulation, like if I want to isolate the tangent squared, I would subtract 1, subtract 1. This is a new trig identity right here, so here's my 5th one. But just to save some time, since you understand that this is what I'm doing, go ahead and write these 2 down. Through manipulation and isolation, we're able to generate these new two from the one we just came up with. we're able to generate tangent squared theta is equal to secant squared theta minus 1. Or this is, the bottom one's actually the sixth one. Secant squared theta minus tangent squared theta is equal to 1. So here's the other two. And we're going to go ahead and, so far we have 6. So we got to do 3 more. Now the other 3 are not that difficult because they're going to follow the same idea. It's going to be a little easier for you to follow because instead of dividing by cosine, you know how we divided by cosine squared theta? Now here comes the question. What will happen if we divide by sine squared theta? We'll generate a new one. By dividing by sine squared theta, we'll make a new trig function. So this is actually number 7. Number 7 is going to be developed by just dividing by sine squared theta. So show the, write the division, and then afterwards I'll simplify with you. So we'll come up with the result. Because the result of this will be number 7, and then we'll do 2 transformations to it, and that's going to result in 8 and 9. So we'll have, then after you have all the results, you will understand and use the benefits to solve different types of trig identities. Very good. Remember, just write down the trig identity and then write simplify. Because one of the things we're going to do, we're going to go ahead now and simplify the equations on the, well, we're going to simplify the equation in general. And in this case, we're going to simplify, y'all see where it says sine squared theta divided and sine squared theta? This simplifies to a result of 1. This is the property that we wrote down in slide 1, which is, y'all remember the cotangent squared theta? That's this one. This one is cotangent squared theta. And then this is similar to the cosecant, except for the fact that it's squared. So with this one, this is actually going to form cosecant squared theta. So this is our 7th trig identity right here. 1 plus cotangent squared theta plus equal to cosecant squared theta. All right, let's, we're going to do 2 other manipulations to this. And then we're going to go ahead and, why don't you go get some water, sir? Get some water. Okay. We're going to do 2 manipulations to this in order to come up and get some, and actually come up with our other 2 trig identities. In this case, the manipulation is going to be the same. We're going to isolate, like the first one we'll isolate is, like here's one of them, cotangent, just by subtracting the 1. Here's one trig identity. You can write that one down. Cotangent squared theta is equal to cosecant squared theta minus 1. That's number 8. And the other one's going to be when I subtract the cotangent. I'm actually going to achieve our very last one. So our last result is going to be this one, the one at the bottom. Cosecant squared theta minus cotangent squared theta equals 1. And that's our last important trig identity. Okay. We're pretty much now developed all the like all the identities, all the armament you need to start solving some of these. And what I'm going to have you do, and what we're going to do, there's one thing that you got to keep in mind. It's going to be very important because you're going to work through it and you're going to realize that you might sit there and actually look at one of these problems on your assignment and you may go ahead and actually do a half-page worth of work and realize that you're not going anywhere with it. You're trying these trig identities, you do about half-page worth of work. It's like a maze. You know, sometimes you go through a path in a maze and you arrive at a dead end. You got to go back. Yeah, so when you sit there and work with some of these problems, you're going to be presented with the same idea. You're going to be there, you're going to work on it. You may get a little frustrated because you're like, man, why is this not working? And sometimes you got to start over. Yes, do it in pencil. And the other thing too is this, that your neighbor says that he proved it, and you look at it and you're like, oh yeah, it looks proved, but it's different from what you did. There's more than one way to do these. There's just not one universal way to do these, because we're talking about manipulating equations, and we'll go through the manipulation. There is something I do want you to write down. Write this down. Your main goal, step 3, which is really the last step of all these steps. Because the first couple of steps, I don't have you writing them down, because I think you should write those down after you had some experience on working with them. Because the number one thing you need to do and get a hang of doing is you're going to keep on replacing trig functions with their identities until both sides of the equation say the exact same thing. The only thing I would add to it is you may have to restart several times. But this is, in essence, the idea of how to get an answer. To arrive at your solution, you got to keep on replacing trig functions in a manner that's going to get you down to where they both equal. That's our goal. All right, let's do something exciting. I'm going to have you pick one out. And I'm going to pick one out because I want to show you if we take, because really what they want you to do is they take these trig identities, they manipulate them, they change them, and they make it look as such in where you are then asked to make them back into an identity function. We're going to create a problem, and then, we're going to start with the solution, make a problem, and then go back to the solution. What I need you to do is you have 9, you know how I talked about these 9 trig functions that we just created off that original sin² plus cosine² theta plus equal to 1? We made 9 trig functions. We made 9. You should have 9 in your notes written off of sin² theta plus cosine² theta equal to 1. That was the first one, the one we did right after the unit circle. Remember we did the unit circle and we did with the Pythagorean? Okay, I want you to pick one of the 9. I want you to pick one of the 9 because we're going to create a problem using somebody that picked one out of here. I'm going to call him somebody randomly. Pick one out of the 9. Pick one. There's no wrong answer unless you pick one that's not one of the 9. Okay. All right. The real right before is selection. Bill. 6. Oh, Angelica. All right. So Angelica. Hey, share with me, Angelica. Which one did you have ready for me? Okay, so you picked the original one, the first one? This one? sin². Okay, equal. Okay. This is how they're going to create a problem for you, and this is what they'll be doing, in essence. Cosine² theta minus 1. I'm going to rewrite it though a little bit because the way it's presented in your homework, the right side, a general rule of thumb is that the right side is not. It's actually not. It's not touched. Yeah, your whole goal is to move the left side and make that equal to the right side. That's the idea of this function. Now I want you to think about one of the original 6, not the ones we made up today, but the ones we worked in the past, sine, cosine, tangent. And I want you to think about that one because I'm going to go ahead and call on somebody to give me one because we're going to change this a little bit to have that function reflected inside of it. Okay? We're going to have that reflected inside of it. So think about one of the original 6. These are the ones that are not in your notes. It could be yeah, pick one of the original 6. Either remember the original 6 is sine, cosine, tangent, cosecant, secant, or cotangent. The ones we worked on before all this. Yeah, like related to the. Yeah, just pick one. You know, there's really not a wrong answer other than just picking one to work with. 20. It's 20. Is it you? You're 17? Oh, you're 20%? Are you 19? So you're the closest one. Remember, the ball's on one that's closest one to it. Now pick one from the other side. Which one do you like for us to use? Tangent? All right, lovely. I like this selection. Let's do tangent. All right, this is what they may do. Okay, they may have this. Okay, this is how they're going to have the problem. And let me share it with you. If I multiply, I'm just going to use what she just did. If I multiply tangent squared theta to both sides, okay, this is how they develop the problem. They'll sit here then, and then this is really, we will distribute this side. Okay, so this will be tangent squared theta times cosine squared theta minus tangent squared theta. And on this side, I'm going to start breaking this up on the right side. I'm going to break it up, and where I'm going to take the tangent and start making it, I'm going to split it apart because there's really not much to do here. And I'm going to do universally throughout the equation. This is really sine squared theta over cosine squared theta. So let me go ahead. On the right side, the way it's going to be presented for you to solve is actually, it may even be presented like this, and where they'll tell you sine squared theta, oops, not sine squared. You see the sine squared times the sine squared? That makes sine to the 4th. They'll say sine to the 4th theta divided by cosine squared theta. And then over here, I'm going to go ahead and change this over from sine squared theta over cosine squared theta times cosine squared theta minus sine squared theta over cosine squared theta. Now, this is one of the things I'll do. I'm going to leave it like this because I don't want to confuse you too much in the sense that I'm going to... No, I know. I know, right. This is... You all might see this, and this is how the problem may be presented to you. This is the creation of a problem. And where I'll tell you, now go ahead and work and make these equal. And you're kind of going to do everything backwards from what we did. What did we do? We went ahead and started breaking, we're going to start breaking things out. Like in this case, you're going to look at this problem, and this is period 7 problem. Now, trust me, your problem is unique from all the other periods because each period I had them create a problem. This is period 7 problem. Now, sine to the 4th power theta divided by cosine squared theta. If this was a period problem and I gave it to the other periods, my other 3 periods I have for pre-calc, and ask them to solve it, they will have to do a few things that you have the pleasure of seeing already. Things that they're going to have to discover that you are showing to them new. First of all, looking at the problem and then deciding that this part right here is really tangent. That you have a tangent squared theta, and that this is really cosine squared theta, and that this is really tangent squared theta. Yes, we did. Let's see. The reason why we're doing it is because we created this problem, and we're acting like it's the first time we're seeing it. Now, what do we do here? There's a tangent in here because y'all see the sign that's in there. So when this is really sine squared theta over cosine squared theta times sine squared theta, right? I know, right? Keep on hearing the thetas mentioned here. Thetas are important in this one. And actually, they're going to be using x's a lot. So you won't hear theta. You might hear sine squared x. And this is what they'll do. And then you'll say, okay, I have tangent squared theta times sine. Was it squared, right? I must have missed a square. Yeah, I lost a square. Okay, I lost a square up there. And then I have this whole thing over here. And then if you're the one looking at this, and you can say, okay, there's a tangent in there in between common. Yeah, you got to factor it out first. You got to just factor it out first, because remember we distributed that, which means that if I factor out this tangent squared theta, I'll be left with this cosine squared theta minus 1. Exactly. Yeah. We're doing this because this is how they make these problems. These problems are done in this exact same fashion. Yeah. So then afterwards, we'll notice that that we have these tangent squared thetas that could divide outright. So we're going to divide the tangent squared theta. It cancels. And then we divide it here. All right, it cancels. Yeah, we're going back exactly. Let's see. Now we go back to cosine squared theta minus 1 is equal to sine squared theta. And we know that this equals sine squared theta, right? So for the grand finale, when you work on these, there's a notation is used in math that is this 3 dots like this mean in conclusion. In conclusion. Yeah, they mean in conclusion. Since we know that this equals sine squared theta, then I have proved that sine squared theta is equal to sine squared theta. And we knew that it was going to be true, right? We knew from the start. There was no hesitant that we were dealing with the guarantee that the cosine squared theta minus 1 is really equal to sine squared theta. Because that's an identity property that we proved in our notes. So, to get the very last solution, we did sine squared theta. We did one that actually was more complicated than maybe some of the ones you're going to see on the homework. But this is how they develop them, in the sense that you know they're going to equal, but you have to find the right way to do the process of them equal. It was an exercise of manipulation. Now let's look at one of the ones on your homework. This will be the fun part. We'll start actually doing more, a little easier examples. That one was a little more, a little bit more intense in the sense that we created our own problem, but involved a few. That's it. I like it. All right. Now, question 1. Okay, let me grab my notes too. Oh, it's over here. Okay, so for you. Okay, now get a separate piece of paper because you're going to need this for this homework. When you turn this homework in, you're going to need to turn it on separate. Yeah, but you're not going to have enough space in just possibly one. Yeah, you may. It could be one of the ones you could turn in. But let's write this down. Now, so our question is secant x times secant x. Yeah, this one won't have so many thetas. We're going to be moving on to x. And this equals to tangent squared x. Okay. Well, this is, go ahead and first write it down. Yes, this is exactly where the knowledge of everything we've done is actually going to be implemented. Now, first of all, I do want to discuss a little bit of tangent of x, especially right now since you're just starting with these. I want you to go ahead and think about what is equivalent. There's two of them that are equivalent to tangent square of x, two identities that we've written down. I want you to name at least one of them. I'm going to call on somebody randomly. Name one of them. So find anybody just have to identify one. Identify one of them. Yes, here it goes. Remember, wait for it. All right, 13. What number are you? You're 10? You're 10, right? Oh, you're 9? 10, 11, 12, 13. So you're the closest one. Yeah. Reagan, give me one of them, as far as one of the identities related to the Yeah. Yeah, this time I'm just going to change them to X though, because that's what they have in here. Now the other one that y'all, one of the ones that we developed was this one, the one with the sine squared theta, cosine squared theta. That one comes handy at times. The other one that we developed as well is secant squared theta minus 1. The reason why I list both is that eventually we're going to have to get down from this equation to either look for the one on the left or the one on the right. And so I kind of want to put a little goal out there in mind so you can kind of know where we're heading to. Let's go back to the problem. The problem is going to kind of dictate which way you're going to go. If you all see the secant on the outside, it kind of naturally lends itself to multiply because there ain't much you could do other than that. So when I multiply secant x times secant x, it makes secant squared x. And then this is going to be secant x times cosine x, and that's going to be equal to tangent x square x. Now currently, the way that the distribution looks, try to make it look like the one on the left with the sine over the cosine. It'll be kind of difficult to try and transform that to look like this. However, the one on the right shows more promise, because if you notice, you all see how it has a secant square x in common. The only thing that is hindering me from identifying it correctly is the idea that on the right side over here after the minus, it doesn't equal 1 yet. Now I need you to prove to me that it equals 1. Find it. I'm going to call on somebody randomly. Look at your identity properties. Make the transformation, which means that, you know how we wrote on our notes? Replace trig properties until they equal. Replace trig properties until you see a connection. I'm going to call on somebody randomly to come up with the solution of that. Alright, 7. That's Mark. Hey, number 7. Now, hey Mark, were you able to come up with the actual identity, or the way to prove to me that this equation on the left equals tangent squared x? Okay. One of the things that if you were to replace one of these trig properties, specifically the secant x, like when you sit here in one of the, and let me show it to you, because once you replace it, it becomes clear. Remember, secant x is really 1 over cosine x, and times cosine x up here as a numerator is equal to tangent squared x. You should be able to see the connection right now. What connection do I see? Or are you seeing? The cosines cancel out, right? They divide out. They become 1, which means that it naturally flows into this property that we wrote down here, in where I could go ahead, and this is how your next 2 steps are going to look like. Secant squared x minus 1 is equal to tangent squared x. And at the very last part of this, you can write in conclusion, since we know that this equals tangent square x, then tangent square x is equal to tangent square x. And you have a solution. And that's all. All that will be done for this one. Yes, once you have that your left side equals your right side, then you are solved, then you are done. Okay, lovely. Let's go ahead and work on another one. Let's work on problem 5 from your homework assignment. Problem 5 is going to be then, number 5, it's going to be cosine squared x plus tangent squared x times cosine squared x is equal to 1. And I do want to give you a tip when you work with these. If you see only sine and cosines on the left-hand side of the equation, or you only see cosines, then change everything just to those. Change everything to sine and cosines. Okay? This is going to make life easier for you, because then you're switching to one common type of set of trig identities. Normally, if you do the same with like secants and cosecants, it helps as well. But a lot of times, just by doing that, it serves you well in understanding the mechanics behind some of the connections. So that means that looking at this problem, the only thing that's not either sine or cosine is the tangent square x. Go ahead and convert it. Do the conversion and see if you can make the connection. I'm calling somebody randomly. All right, let me pick on. Let me go ahead and select somebody. All right, check. 11. So, what did you do? Did you come up with something? Well, the first thing that they should have done, because see, this is the only thing that's not in terms of sine or cosines. So everything should have been, we should have changed this out to its identity property, which is sine squared x over cosine squared x times cosine squared x. And then you should have, then a connection should have been made from here. And if you notice, what is the thing that you're able to do? Yeah, cancel out the cosines, right? So this is going to cancel with this. And I'm going to be left then with cosine square x plus sine square x is equal to 1. And this is the original identity property we started with, which means that, therefore, your very last step, you're going to go ahead and write that 1 is equal to 1. And you have solved it. And that's how you work on this. Okay, excellent. Hey, listen, we'll go ahead and